Hello, and welcome back to the Intro to Python lecture, where we'll be going over the implementation of a lot of the things that you've been learning in the past two videos. Now, implementation of this is extremely important because this is most likely the main things you're going to use for the rest of this course, so it's important you have a solid grasp on syntax. Now let's get started with the basics. Now, the basics of this course are obviously dependent upon variables and data types. So let's quickly look at some elementary functions and data types and how to see them in your syntax. First, booleans, floats, integers, and strings. When naming variables, obviously make sure that they aren't keywords, like the word bool that I've already shown changes a data type into a boolean. But rather use actual names like bool1, and keep in mind that for booleans, the words true and false with a capital T or F are keywords, so they will turn this color blue. Same thing with floats and integers. As you can see, the number turns green because it signifies that there is a number being used as a data type. With integers, the same is true, and the same goes for strings as well, that turn a dark brown with double or single quotes. Next, let's look at exactly how these interact with each other and how we can convert them into different data types. Now, we've already seen some examples of this, like I've mentioned with the bool and the str keywords. But let's understand that in detail. Say I want to convert float1 into an integer. I'll name this floatInt just for naming for sake. If I do int, which is a data conversion function, and I put float1, what you will see here is that floatInt, or 1.0, has now become the integer version of, 1.0. Now, to prove this, let's just print what floatInt comes out to be. Oh, just a second. As you can see, it comes out to 1. And just to make sure, even if I do the type function, which, like I've mentioned before, gives you the data type of any certain variable, it'll give you that it's an integer. Now, you can do the same thing with many other types of keywords. Let's take, for example, the boolean. Let's say we have a string here that says string2 equals true. If I do string bool, and we convert the string into a boolean, we can do the bool keyword and use the string2 as our argument. Now, just to make sure that this argument is in fact the right one, and that we actually get a boolean as the resulting data type, let's just quickly check. And there, as you can see, we've gotten bool. Now, let's go to the next section of this implementation and understand the input function, which is heavily important when it comes to data conversion and how exactly you can use it in your code. Let's take a quick mathing problem. For answer to a problem equals input. Here you put in your prompt. What is 2 plus 2? That will be our prompt for today, just as an example. As you can see, when I say what is 2 plus 2, a text box shows up, and you can input the number 4. Now, for Jupyter Notebook, a text box shows up, but for many other things, sometimes it isn't a text box, but rather just a blinking cursor waiting for you to input. But when we put what is 2 plus 2, 4, we can see that the next time we do it, it will get stored into answer prob. Like so. However, look at these single quotes. This means that this is in fact a string. To prove this, let's quickly find the type of answer problem. And yes, it is in fact a string. Now, what makes this so bad? Let's create another code cell here and show you. Now, let's say you want to find or add the number that the user gives you to another number, like 4 plus 6. Now, to do this, you would obviously take answer prob and then plus 6. But we'll be getting an error because you can only concatenate string, not int. In other words, you cannot add a string to an integer. So how do we fix this? Well, let's go back to answer prob. How can we change the type so that it's a string, or that it's not a string and can work with an integer like 6? Well, the answer is quite simple. Let's just change it to an integer, like so. And just like that, you get the right answer of 10. With the input function, it's extremely important that you make sure and you realize that input always takes in strings, and you always have to change them to integers or floats or booleans depending on what is necessary, because most of the time you really won't be using strings if you have math problems. Now, let's go into our next section, which is some elementary operations. Now, we've already seen, I think, the most important example of ordering systems and elementary operations with the range function. And what the range function does is it gives you a set of values between a number or two numbers that you've specified, and you can even determine the step as well. Let's take, for example, range 0 to 4. Now, what this does, it will usually print out the numbers between 0 and 4. And when you put the number 2 here, it'll print out the numbers, well, it'll print out the numbers 0, 2, and then 4, because it skips a step by 2. The step function is important because it determines the space between each of your numbers, and can therefore change exactly what numbers are inputted into the range function. We'll get into more detail in this video when it comes to the for and while loops. And that's exactly what we're going to be starting with now. We'll start with the while loop and get into the for loop and see how exactly the range function is used in the for loop. Now, let's take an example of y, that y equals 0. Now for a while loop, remember that while y is less than, you can use equal to, or you can use the greater than, but we'll use less than for now. Well, y is less than 10, we can just print y. And this is special notation, but it's y plus equals 1. What this does is it adds 1 to the previous value of y. Now what happens is when we run this, we get all the numbers from 1 to 10, except 10, because it's strictly less. While loops are extremely important, and it's clear that you shouldn't be using an equal sign, but rather a doubles equal sign, because an equal sign doesn't give you a truth value. And this clearly will not return anything because y will never be equal to 10 until it, of course, finally is, and in that case the program will just stop. Now let's look at another loop that is extremely important in how exactly it factors into the range function, and that's the for loop. So for x in range, like we mentioned before, 0 to 4, let's just say print x. Now, as you can see, we get the numbers 1, 2, and 3, right? Now, let's try this with a different sort of data type. Let's just say we have the x equals banana. Now, if we do for x in banana, or for y in x, print y. Now, what this does is imagine y is a letter. It'll print B-A-N-A-N-A, because for all the y that are in x, so for all the letters in the word x, which is banana, it'll print out said letter. As you can see, for loops are extremely versatile, and we can use them not only to parse out information from strings, but we can use it to use for numbers as well. Now let's look at a conditional, the if statement. Let's give the example of the answer to the problem. Answer equals 4. Now obviously, if the user inputs the wrong answer, then we have to say that they are wrong. So let's say if answer is equal to 3, then we say print your answer is 3. You are wrong. Obviously nothing will happen here, but if we change this number to 3, just like that, we get your answer is equal to 3, and you're wrong. Now this will work equally well with the elif statement. If ans is equal to 2, you can just print answer is 2, you are wrong. And finally, the else statement. If all other things do not apply, we can just say your answer is right. Of course, this is a wrong logic to follow, but this is just a basic example. So let's see what happens when we put in 3. Your answer is 3, you are wrong. It goes through this first condition. If we put 2, it'll go through the first, then the second, and it'll figure out that it's connected to the second. Say we put 7. it'll go to the first, the second, and if all else fails, it'll go to the final else statement. That's extremely important to know because usually the else statement will be the outlier, or rather, not counting for all outliers in your problem. Next, let's look at the second, or rather the third part of our lecture today, and that's lists. Now lists are extremely important because they're the only variable in the basics of Python that actually can hold multiple data values. Let's look at an example. List 1 equals square brackets 1, 2, 3, 4, 5, 6, 7. What this does is when we just show list 1, it'll have multiple values in it. The same thing applies for another similar data type, a tuple. A tuple 1 will give us 0, 1. When we show this tuple, it shows two values, 0 and 1. Now tuples are usually used for coordinates, but in this case, the most important part of this lecture will be about lists. Now let's look at list indexing. So say we want to print the index of a list, right? If you remember correctly, its index start from 0 to 1. So if you print list 1, 0, it should print, as you can see, the first term, which is 1. Let's go down the list and see exactly how indexes interact. If we do print list 1 of 1, what happens is we get 2, which is of course the second value in the list, but also the one that corresponds to index 1. Now let's look at some other slicing methods for indexes. If we print list 1 of, say, 1 colon, what this does is give you all the values after the 1, or the index 1, namely 2, 3, 4, 5, 6, 7. And this applies again. If we do the opposite direction, list 1, 3, but we put a colon before, we'll get 1, 2, 3. And finally, what could be the most important use of slicing is when you're using two distinct values. Say you have 2 and 4, two different indices. When you slice, you get the values between them, 2 and 3. This last value is usually not counted. It goes to 2 and 4. And therefore your results, as you can see here, are from index 2, which is 3, and index 3, which is 4. We'll do one more example of this just to make sure you understand the implementation and exactly how the syntax works. Let's take 1 and 5. Again, obviously what this will do is it'll print the first index, second, third, and fourth, but it will not print the fifth, as you can see here. Finally, the last part of our implementation section, or the last part of the list section, will be going over list comprehension, which is an easy and simple way to make lists with one command. First, let's look at a list that you have to use to create between the numbers 1 and 7. What you would usually do is for x in range 1, 7, or, sorry, no. What you would usually do is x equals 1, 2, 3, 4, 5, 6, 7. And this is pretty efficient, but only on small numbers. If you need to add, say, 1,000,000 numbers, you would have to create a 3-line for loop. However, with list comprehension, that all goes out the window, because all you have to say here is we'll do list underscore comp. And we'll do the same exact list up there, but in one line, and make it a lot easier. First, let's put our expression, or what exactly the list will be taking in, and that's x. You'll understand this in just a minute. Now we'll say what we're doing to x, or rather the value of x, as it approaches or as it moves around. In this case, we want the values of x in the range of 1 to 8, or 1 to 7 in this case. So we'll do for x in range 1 to 8. Now, when we see list comp, what happens is we see our same list that was up here, except a lot more efficient, and I'll explain why. Now, say you wanted to square all the values in this list. I'll rename it just list 3. Right? Say you wanted to square all the values. Well, what you would do is list 3 squared. And obviously that doesn't work. However, for list comprehension, you can do this super easily. All I have to do is add in the expression that you're squaring it, and boom. That's what makes list comprehension very powerful. Another example of list comprehension is also with the if statement. List comp if. Let's say we want to get all the x squared values for x in range 1 to 100, but we only wanted the ones that were odd. So we'll put a little modulus function. Modulus, by the way, means remainder. And we'll say for x mod 2 equals 1. That basically means that x divided by 2 will always have a remainder of 1. Now let's see what happens to our function list comp if. As you can see, we get all the values that are odd. There's not a single even value in here, and that's because we can use the power of if statements to ensure that we filter out all even values. Finally, let's look at the last part of this section, and that's functions and lambda functions. We'll start by looking at the basic rudimentary definition of a function, which is def func. We'll put any arguments in here, say x equals print x, and then when we call our function, we'll just do function ola. What this does, it'll obviously print ola because that's the argument we're putting in here. Now functions, of course, can also return values. We'll call this def fruitful. Return y to the power of 2. What this does is it returns a value, and that doesn't mean it prints it. All it means is that it gives a value out to be stored later. So in that case, we'll have to use a variable or a print statement. In this case, let's just use a variable. We'll say result equals fruitful of 12. We all know the answer is going to be 144, but let's see exactly why a fruitful function is different. As you can see, it stores the value of this function in fruitful. If you use this function, func, it won't store the print value in some arbitrary variable, but this will store 144 in result. As you can see here, even Jupyter Notebook shows you that 144 is stored in the integer result. This is a rudimentary function, but as you go on, your functions will most likely get more and more complicated. And finally, let's look at lambda functions, which are extremely important to keeping your code concise. Now, lambda functions are usually done like this, where you have the name. In this case, we'll just put an arbitrary name of lambda example, and in this case, we'll just do lambda of x, which is in this case our expression, like we mentioned in list comprehension. And then we'll put any arbitrary value, say x plus 200. Oh, I misspelled lambda. 1 second. Yeah. So now what happens is whenever you input, or whenever you call lambda example, you input a value of x. In this case, let's input 190. Obviously, it will return 390 because it's returning x when x is plus 200. Let's look at another example. This will return x to the power of 30 for any number that we input. Lambda example 2, let's just put 2 because this is a big number, and it'll return 2 to the power of 30. So this is about all for the implementation section. You can go over this notebook later, but the basics are pretty similar here. Just go over the implementation and make sure that you have all the syntax down. For example, square brackets for lists, or how to convert data types. Good luck in the future sections of the course, and thank you.